Okie dokie. Well, so if we look here at task 2.5, we want to use a normal distribution to do our hypothesis test, or really to compute our p-value, the probability of being at least as extreme as our data. Okay, so I need to create a normal distribution now. Now we'll just work with the proportions. So things are similar, but I've kind of moved the 33. There's no 33 in the mean anymore because I just want to use the proportion. And now that n ends up being in the denominator inside this standard deviation calculation. So I'll do that, and it says, hey, make a new Desmos graph and so forth. And yes, I suggest you do that. Make a new one. I'm not going to. I'm just going to go back to the one I did in the last video. Now, I don't need this histogram anymore, so I'm going to get rid of that. And now to get this mean, I just want m to be 0.59 now, so you see it moved it way over here, so I'll have to recenter things and so forth. In the standard deviation now, that 33 doesn't go there. It needs to, I'll say divide and 33, and there's that standard deviation of 0.0856. And now I actually, I use an S here because it's just easier, but you can use a sigma. If you start typing out the word sigma, S-I-G-M-A, oh, it didn't do it. So I lied. I thought it would do a sigma if I did it. It does some other Greek letters, but okay, so we have that. Now this picture of course looks horrible, so what I want to do is go fix it up here, and actually I guess what I may do is I may zoom in. Okay, so I'm going to zoom in until the X is where I'd like it. So that looks pretty good. Okay, now the problem is this is really tall. Well, how tall? Well, I know actually it shouldn't be too tall. This goes from 0.2 to 1. And I know that total area under the curve is a probability, or it has to be 100%, a 1. And so, I don't think this could be much taller than 1, just kind of thinking of a rectangle of width 0.8. And, so it would have a height a little more than 1. So, I'll kind of start there, y-axis. I'll type in 1. See, that's not quite enough. Shouldn't be too much more than that. I'll try a 0.5. Oh, well, a little more than I was thinking. And heck, I've had to do this. I made that picture already. So, okay, well, maybe it was taller than that. Let's try a 2. That's still pretty bad. Okay, but now, let's see, I've got it in a little better shape. So now, I can kind of get the y-axis where I want it. And now I'll just make the x-axis look a little better. So maybe I'll try going from 0, or maybe 0.1, just to make it look a little better there. And go over here to, maybe, what's it look like? Maybe 1.2. Make it look pretty good. Okay, so you should, get your, oops, I did Y. Silly me. Let's see, can I just say undo? I don't think I can. Nah. So I don't remember where it was, but let's see. So see, I messed stuff up too. 2.5? 2.95? No, must have been, well, that's way bigger than 4, 5. No, so it was about 5. Wow. Okay, so 5 works. So I'm, so hopefully you don't have to do that. You'll do it here. Okay, and then what did I say? I think about 1.2, and and then I can just kind of move it a little bit if I want to, but that looks really good. Okay, so there's 1.2 for my width, and so there I have my normal distribution. And now what we want to do is use this, find the cumulative probability thing here. Okay, so if I do that, it shades everything in. But see, what I want to do is go from, change the minimum and maximum, because see, right now it's telling me 1 or 100%. See, it's saying that the probability of being somewhere in this distribution, if I sample it, is 100%. Well, sure, if I sample from that distribution, I have a 100% chance of getting something from that distribution. Okay, but what I'm interested in is how likely I could get my data. So my data for the African American Black doctor group was a 0.7 or higher. Okay, because again, I'm asking the question of how likely is it that I could have gotten 0.7 or even higher, farther away from the 0.59 than I got. And I do, so I just put that in, go to infinity, because I want to look here all the way to the right, and just ask, well, how likely is that? And what I see is it's nearly 10% of the time that could happen. And so, if it's 10% of the time, then I'm going to say that's likely enough that my data that came in at 0.7, I really can't use that as evidence to say that the AAB responses were any higher than the general average. Okay, so I would think they really are. They really are coming from populations with different proportions. I think so, but I cannot use these data as evidence to support that very well. Okay, using our hypothesis test here, because it's 10% of the time. That's a lot. Okay, I mean, when you think about it, if you could go out and have a 10% chance of winning a lottery of $200 million, you would probably take that chance, because you would think, well, that's a pretty good chance of getting $200 million. So a 10% chance, pretty big. All right, but that's how we create our normal distribution for our sampling population here, and then how we check based on this sampling population, or our null hypothesis, how we check to determine for our data our p-value. So right there's my p-value, and it's pretty big. Okay, it's well over 5%, our threshold, and so unfortunately that does not allow me to refute the null hypothesis. Okay, so there we go.